This is lesson 3.7, which is on solving quadratic equations, specifically with fractions. So it's a continuation of lesson 3.6, where we were factoring quadratic equations and then solving for the x values, or whatever letter they used. And so this is pretty much the same thing, but what happens when we have fractions in the equations, which nobody likes. It's just a tip as to how to deal with the fractions, but then everything else is pretty much what we did in lesson 3.6. Now there are instructions right here, and the homework is 3.7 homework page. Okay, so let's get started on the first example. As always, I like to just teach through the example instead of, the steps, but you're welcome to look at the steps if you'd like. So if you have the lesson in front of you, the equation is x squared over 20 equals to x over 5 plus 1/4. Now there's a lot of fractions here, and what we ideally want it to look like is something like this, a simple trinomial without any fractions, because it's just easier to factor and then solve. Now the way that we get rid of the fractions, and we've done this before, is we find the common denominator. So we have 25 and 4, and so the common denominator between all three numbers would be 20. And so notice that I've multiplied the entire fraction on the left side of the equation and everything on the right side of the equation with 20. So I've indicated that in front of the brackets. I know sometimes you don't have a lot of space and you want to write it behind. If you do write it behind, please put the times symbol and then 20, because if you just put the 20, it looks like to the power of 20. Okay, so just for communication marks, make sure I usually just put them in the front. Okay. Now when you do that, let's just work on the left side first. You're going to take that 20 and you're going to multiply just the numerator, because underneath that 20 is an invisible 1, and that 1 is going to multiply the 20 on the bottom. So don't multiply 20 on the top and on the bottom, alright? Just on the top. So notice that I get 20x squared, and the denominator remains the same at 20. We're going to do the same in this right side, where you take 20 times the first fraction, so 20x on the top, leave the denominator alone as a 5. 20 times the 1, which will give you a 20, and then leave the denominator as a 4. So that actually didn't get rid of any of your fractions. But notice that each of the fractions can be reduced now, and the denominators will disappear. So now we've gotten rid of the fractions, the denominators at the bottom, which were what was causing the trouble in the first place. Now we're just going to solve just like we did in lesson 3.6. So we want it to equal to 0. So bring everything over to the other side, and notice that the symbols, which were positives, changed to negatives. Then what we're going to do is we're going to notice that this is a simple trinomial, and so we're going to factor two numbers that multiply to -5, they add to -4, are going to be 1 and -5. From there, you're finished factoring. Just make sure that you write the equal 0, and then you're going to start the process of solving. Okay, so by solving, you're going to take the first bracket and equate it to equal 0. Bring the 1 to the other side, and you get the final answer of -1. The other one you're going to equate to 0. Bring the -5 to the other side, it's going to become a 5. So your answer for this equation with fractions is -1 or 5. Now we can check our answer over here. So this is the check for the answer of 5. This is the check for the answer of -1. So if you're checking 5, what you're going to do is take the left side of the equation, x squared over 20, and the right side of the equation, x over 5 plus 1 over 4, and you're going to sub a 5 in anywhere you see an x. So this side I'm going to work on separately. Sorry. And this side I'm going to work on separately as well. So summing a 5 in, 5 squared is 25. 25 over 20 I'm going to reduce to 5 over 4. Plugging the 5 into the x on the right hand side, this will create a 1. which makes 1 1/4. In other words, 4/4 plus 1/4, which is 5/4. They match, which means left side equals right side. So 5 works for this equation to be balanced on both sides. You do the same thing with the -1. Just make sure that when you are subbing it in, you put it in brackets if it's squared, and that'll give you a positive 1/20. Put the -1 over into the x, which is right over here. I didn't put brackets because it wasn't really interacting with anything. -1/5 plus 1/4 make the denominators the same, and you'll get the same 1/20. So -1 also works for the original equation with fractions. Now, don't do the check every single time. If you have time to do it, then do it. If you don't have time to do it, then only do it if the question actually asks for it, which it doesn't. So notice that the second two, or the last two questions, I haven't actually proved with the check. Okay? So let's do this again. We have an equation that has fractions, and we want to get rid of those fractions first. So find the common denominator. 2 and 3 make a common denominator of 6. And so we're going to multiply both the left side and the right side of the equation with 6. And that 6 will only multiply the numerator. It will not multiply the denominator. So notice that this new fraction is going to be 6x squared over 2. 6 times the next fraction will be 6x over 3. And that's equal to, and then we're also going to multiply the right side of the equation, because remember, whatever you do to the left side, you do to the right side as well. Multiply the 6 to the right side of the equation, 24 over the same denominator of 3. That step does not get rid of your fractions. You'll have to do an additional step where you divide each one, and then you'll get your fractions to disappear. Now, some of you guys can do this very quickly and jump from this step to this step, and that's fine. You don't have to write this step if you don't want to. Now, from this, what I have to do is make sure it equals to 0, so I'm going to move the 8 to the other side, it makes a negative, and because there's no numbers that I can pull out by common factoring, I notice that this is a complex trinomial. The first and last numbers are also not square rootable, so it's not a perfect square trinomial. So I'm actually going to go through the process of decomposition. Two numbers that multiply to the 3 and the -8, so 24 negative, but add to -2 are going to be -6 and +4. So we put those there with the x's and bring down the 3x squared and the -8. Then you're going to factor by grouping the first two. It looks like a 3x can come out with the leftovers of x minus 2 from these first two terms. And then the last two terms, it looks like I could pull out a 4 with the same leftovers x minus 2 in brackets. And so the final answer from factoring is taking that x minus 2 away from both and putting the 3x plus 4 into a leftovers bracket. So this portion is simplifying, then you're factoring, and this last portion is solving, where you're actually going to just tell me what the opposites are in each of the brackets. So x equals to 2. And then if you can't find the opposite in this bracket, you just set it equal to 0 and do it the long way. Bring the 4 over, -4, which is the opposite of +4. And then dividing by 3, which is the opposite of a 3 multiply in this scenario. So I didn't state what I had stated here, that therefore it's not necessary. You can just leave it like this, or in the final question I'll show you more streamlined the way that I personally would write a solution. So let's do this one more time, but with less steps. Okay, so noticing that first of all it has fractions, there's an equal sign, so I can get rid of the fractions by multiplying everything by the common denominator, which is 15. So 15 multiplied this one. The 15 will multiply just the numerator, so 15x squared, and then times 15, times the 15 and the 1, you're going to get 15, all over 5. 15 times x, which is right here, subtract 15 times everything in the numerator here, so 15 minus 15x squared, all over 3. So you're still going to have your fractions, That means take the entire numerator and divide by 5. So you're going to get 3x squared plus 3. And that's done. The 5 disappears. 15x squared is there minus, and you're going to take everything in the numerator and divide by 3. When you do that, be careful that every answer or every term in that answer is going to be surrounded by brackets. And that's important because this negative is going to switch the symbols of each of these terms. So you're going to get a negative 5 and a positive 5x squared in the next line. Notice that I kept everything else the same. All of this has been simplifying, getting rid of those denominators, and the last thing you're going to do is just make sure it equals to 0. So I brought everything on this side, mainly because this has a positive 5x squared starting off. So when I bring the 3x squared over and I subtract, it'll make a positive. If I had brought everything over to this side, I would have gotten a negative 2x squared, which I don't really know how to factor very well, starting with a negative. We've always seen our trinomials starting with a positive leading coefficient. Okay? Alright, so let's get back on track. 5x squared. Bring the 3x squared over to the other side is negative. Bring the 3 to the other side is a negative. When you clean it up and collect like terms, you're going to get a complex trinomial. And you can either factor by decomposition or the guess and check that I showed people at lunchtime. And you're going to get a final answer of 2x minus 1 and x plus 8. What you can't do is forget about showing the steps of the solving. You're just going to do the opposite of the negative 1 divided by the 2. Opposite of the positive 8. And you get negative 8. And you can do that all in one step. So this is what I would the number of steps that I would actually write myself just to make it more streamlined. And that's lesson 3.7.